Nope.
Okay.
Number 12. Today, this is the second part of the homework, page 57, 58, 12 through 18, and page 56, 8 through 10. Let's start with number 12. It says, determine the interest. Okay, first of all, interest is a different kind of question. They don't want the final amount in it. They want the actual interest. Earned after 5 years, so T is 5. That had an initial investment of $25,000 at a 3.5% interest, compounded daily. Compounded daily. Because of the word compounded, we are using this formula. Okay, we want the interest. So first we're going to start P55,000. 1 plus 0.035. How many days in a year? 365. So this is going to be 365 times 5 years. Okay, let's figure this out. 25,000 parentheses 1 plus, can you guys see that? 0.035 divided by daily 365 raised to the 365 times 5. Right? So we had this much money, but we have to subtract the initial investment of $25,000 for an interest of $4,780.90. That's your interest. You actually have $29,000 in your account, but that's not your interest. You have to subtract the initial $25,000.
Okay, I knew it. So I did write another one, so that would be subtracting 2. So 85 and 85 is correct.
13. Determine the balance after 10 years.
Maybe one more missing. I'm going to keep going through this.
This one just wants the balance. So this one's asking for balance. So this is not what we just did. This is the actual money in the account. That had an initial investment of $25,000. I feel like I just did this problem. That's a different problem. P is 25,000 at 3. Okay, this is very similar to the last one. But this one says compounded quarterly. So not only is the money going to be in there longer, it's going to be in there 5 years longer, but it's going to be compounded more or less often. Quarterly, 10 years. So we have pretty much the same thing we had last time. We have 25,035, but this time it's compounded quarterly, so that's divided by 4. There's your 4 again, and this time it's times 10 years. So whatever we get on our calculator is our answer. I actually feel like I want to go, I'll just type it in again. So 25,000, parenthesis, 1 plus 0.035 divided by 4, because it's quarterly, raised quarterly for 10 years, times 10. So you can write a 40 in there, or the 4 times 10. Did I have everything right? So that's $35,422.72. That's their balance. So it looks like they've made over $10,000 in 10 years. That's not a bad gig right there. I like it. 14. What do you need to prove? Determine the amount of money that needs to be invested at 6%. They're asking us how much money should be invested. So this time we don't know the P. We don't know our initial investment. Okay, compounded monthly. Compounded. That's N, by the way. Compounded monthly means N is 12. To have $20,000. So we're going to have $20,000. That's our goal. That's the amount of money we want to have in our account. We want that to be our balance in 15 years. So this time, when you have this formula, this time we would like to have 20,000. That's our goal. So how much money would we have to invest? So this time we don't know P. Our interest rate is 6%. It is monthly, so we're dividing by 12 for 15 years. So I need you to punch all of this in the calculator and get a number. And then we're going to divide it to the other side. And that's how you figure out how much money you should invest. So we have parentheses 1 plus 0.06 divided by 12, parentheses, raised to the 12 times 15. So monthly for 15 years.
It was like a thing. Don't worry about it. That was their parents.
So this is P, or 2.45409 P equals 20,000. And we're dividing by all of that. Now I'm just writing a bunch of numbers down right now, but I want you to keep this on your calculator. We're going to type in 20,000, and we're dividing by this number. We're going to copy and paste this. We're going to copy. See how I copied and pasted that? Press enter. That way you don't have to worry about rounding errors. And then you press enter. That's how much money you would have to initially invest. So your initial investment should be that much money. You should invest about $8,149.65 if you would like to have $20,000 in 15 years with a 6% interest, which, by the way, 6% interest is really high, but that's how you do it. 15. 15. Oh, I love tables. Don't you love tables? So we have our first one. All right, so we have $10,000. We have to make this chart. So P is 10,000, by the way. 5 years is T for the first row, and all the interests are different. So I'm going to fill this. I'm going to do the work over here, but I'm filling in the table in the book. So basically, you have. Here's your formula. Are any of these compounded? Yes, they're all compounded. So we're using this formula for all of these. Okay, so we're going to invest $10,000 for all of these. 1 plus the first interest is 5% annually for 5 years. 10,000 times 1 plus 0.05 raised to the 1 times 5. So the first one is $12,762.81 or 82 cents. So I'm going to come over here and write this in my book. All right, so here's your table. So the very first one was $12,762.82. Okay, I don't even have enough time to. Maybe we shouldn't worry about the pennies. What do you guys think? So we can fit this in here. Now, what is the change if I said quarterly? So it's basically everything's the same except I'm going to go back up here. I'm going to go up here to this. All right, so I'm going to go backwards. So this part right here, I'm going to press divided by 4 because it's quarterly. Raised to the 4 times 5. So when you do quarterly, oops, I need to get rid of this other 5. I have a box. That's probably going to mess that up. All right. So it's quarterly. Do you see how I put the 4s in there? But it's still for 5 years. That should be good. So that is 1,010. I'm not even going to worry about pennies this time. So it's 1,288.20. So I feel like that doesn't make sense. Oh, wait, that's more money. Yes, this is more money. You should have more money than this one. It's close. This is 12,762. This is 12,820. You should have more money because the more money times your money compounds, the better for you. So now we're going to do monthly. Everything else is the same. So we're going to come back up to here. I don't know what I'm doing. All right, let me just do this. Second enter. There we go. Just press second enter. I'm changing this 4 to a 12. Okay, monthly. Now I need a spot, so I don't have to mess up my parentheses. There's a little way you can do this by pressing second delete. That's an insert. And I can insert an extra number because it's a little bit bigger. Oh, but I messed up my parentheses. Darn it. Insert parentheses. There we go. And then I'm going to put a 12 in here times 5. See how I entered that? That's monthly. It looks just like the quarterly one, except I'm dividing by 12, and I have an extra 12 in the exponent. Press equals, and that is $12,833. That's only $13 more than the previous one. So monthly is still better than quarterly, but only by $13 in 5 years. And the last one is weekly. How many weeks are in a year? Press second enter to bring that back up. There are 52 weeks in a year. So I'm changing the 1 to a 5. And I'm changing the one up here to a 5. There's 52 weeks in a year. There is 52 weeks in a year, right? Or is it 26? I can't think. All right. So enter. So this one is $12,838. That's only $5 more. Okay. So all the answers should be close, but that's how you do it. So now this next part is 10 years. So how does all this change? I'm going to go back up to my work here. To this one right here. See how this one was 10 years? Everything's the same except it's 10 years. So I'm going to highlight it and I'm going to press second enter. Did that work? I don't think that worked. Copy paste. All right, I don't know what I can't remember how to do this. I'm just going to have to go back and do all this.
Oh, I see.
Let's do it. Oh, let's do this again. All right, so we have 10,000 parentheses 1 plus. The percentage is still the same. 0.05 annually means divide by 1, so we don't need that. Raised to the 10 years. So this is our simple interest one. So this is $16,288.94, but I'm not worrying about the pennies. So this is quite a bit of difference with 5 extra years. So we're going to do quarterly. So we're going to press second enter. We're going to come in here. We're going to press this divided by 4. Raised to the 4 times 10. So in other words, it's 40. Oh, I knew that something was going to go wrong. Oh, I have something completely wrong here. What the heck just happened? I got to type this in. 10,000. 1 plus 0.05 divided by 4. Raised to, I'm just going to put 40. Quarterly for 10 years is 40. So that is 16,436. So it should be more money than the first one. The next one is monthly. So I'm pressing second enter. See if I can get this right this time. Monthly. This is 1, 2, parenthesis, raised monthly 12 times 10 years. This is where I keep messing up. Oh, what did I do? Oh, there's a 0 in there. I don't know what I'm doing. Someone help me. 10,000 parenthesis 1 plus 0.05 divided by 12 raised to the 120. 12 times 10 years. 16,470. And the last one is weekly. I'm going to get this right. Change this to a 5. Change this to 10 years, 52 weeks. It's 520. 16,483. So it's slightly higher each time. That was an annoying problem. I apologize. All right, 16. Actually, I'm just going to start in the book here. 16. Harry has 31 to invest. Okay, that's P. 3,100 to invest. In 2 years, he needs 3,500. So in 2 years, he needs 3,500. In 2 years. Which investment will allow Harry to meet his goal? So if you like this amount to be 3,500 and you're going to start with 3,000, do you need the first one to be 4% compounded weekly? So let's look. Weekly, 52. 52 times 2 years. Let's see. Is that going to be what we need? Nope. It's not the first one. So because that was so off of my 3,500,
Oh.
I'm going to go, well, I'll try quarterly. Let's just go to the highest interest rate. Let's see what the highest interest rate. Let's see if we can go the lowest and the highest and see if where we're at. Let's try D. D is compounded annually. So it'd be 3,500,
Oh, yeah.
3,000. Compounded annually would be 8% in 2 years. So that's a simple one. Do you see this? So just type in the right-hand side. Just type in this and see if it equals 3,500. If it does, answer is D. So parentheses, 1.08 raised to the second. Ooh, I say that's it. 3,499. I don't think it's going to get any closer than that.
What do you mean how?
I'm saying D.
You did it.
16 is D.
But you did it. So
16 is D.
Wait, does it really say the same check number?
Yeah. 2427. 2427.
Okay.
The chart for 15, I should probably write this down for people that are just looking at the paper. 12762, 12820, 12833, 12838. That was the first part of the chart. And then 16288, 16436, 16470, and 16483. So those people that are looking at the paper, that was the chart answers.
Give me minus one balance.
All right, we're on 17. I got longest homework ever. What was I thinking? 17.
Just forget.
How much additional interest could $15,000 earn in 20 years, compounded monthly, if the annual interest rate were 5.14 as opposed to 5%? All right. So if you had $15,000,
Oh, Jennifer.
1 plus 5 1/4. Okay, so 5 1/4 looks like this. So if you move the decimal 2 to the left, it's 0.0525 for 20 years, compared to 15,000, 5% for 20 years. I think that's the only numbers I need, right? So we're going to compare these two numbers and see how much more interest we would earn if we took the higher interest rate, 5 1/4 over 5%. What does 1/4% do to your money in 20 years? We're going to show you. That 1/4 of an interest rate should be a huge, significant number.
Why'd you do the initial first name?
20 years, especially for the more years like that. So there's your 5 1/4%, 20%. So this one is $41,738.16. So that's if it was 5 1/4. Okay, if it was only 5%,
16.
Check the other zero. That's like multiple zeros.
17.
I would make 39799.47, and then I would subtract this one, that one, minus this one. Wait a minute, let me see. Additional interest. I'm not sure if, okay, I'm going to have to do this again. So we're going to take $41,738.16, and we're going to subtract our initial investment of $15,000 from the first one. So we would make an interest of 26. Ooh, that's a lot. That's how much interest you earn. Good God, that's a lot of money.
Oh, that's when I just.
That's how much interest you would earn in 20 years at 5 1/4. That's how much money, extra money you make outside of your investment. So the other one, you would take 39799.47 minus the 15,000, and your interest would have been 24,799.
Just count the yellow pages.
So what is the difference? Now we'll take this one, this number right here. I highlighted it, minus this number, highlight it. So you would have made an additional $1,938.69 for 1/4 of an interest difference. That's almost $2,000 for 1/4 of an interest. So is 1/4 of interest important to you? You should say, heck yeah, we want the higher interest rate when we're investing our money. All right, 18. If the balance of 20,000 grew to 29,816 and 66 in 10 years, this is P and this is A, determine the rate of interest. Okay, so here's our formula. So if 20,000 grew to this, what would your interest rate be after 10 years? So the first one says 4% compounded weekly. So if it was 4%, oh, that's what the answer. They just wanted to figure out our interest rate.
So it's 88. Yeah. Now we gotta look at the spreadsheet and see who's not there.
Okay, all right, I'll tell you their names.
So we got to try these. 4% weekly. Is that the answer? It's a multiple choice question. So we're putting 4%. This is choice A. So punch all this in and see if it's 29,000. So we're going to go 20,000
Oh, wait, I don't even want to say it.
parenthesis 1 plus 0.04 divided by 52 raised
The last count, that
to
had
the
87.
520
So then my real count would have been 86.
is 2981.
No, it's 88 out of nowhere.
3-1. Very close. That's not it. So let's make some tweaks. So this was choice A. Choice A did not work.
Wait. 88, and then minus the 4.
Choice
I
B.
subtracted.
Is it 5% compounded weekly?
84 still would help us. Well, they would need to be closer to their
So
Actually, no.
Yeah, the actual number
is it
92.
5%?
Minus 4.
Oh, this is not even the same amount. Yes, it is. 5% weekly. So this is still the same numbers. But we changed the interest rate, so let's see what that is. No, that's too high. So it's not B. Choice C. 20,000.
Possibly.
Interest rate for C is 4%,
I know, but it still has to be
but monthly. So we press second enter.
paid.
We went
I
4%
saw her number.
monthly at the 2. This would be 120.
And depending on what
You
the
see
other
that?
person.
That's exactly what I have. This is the answer. C is the answer. Okay, so there's that. Ooh, that's 12 through 18. That's a lot of problems. All right, the last one is page 56, 8 through 10. Okay, so page 56, 8 through 10.
Yeah.
An account that was invested at 5% with continuous. Oh, continuous. Let's go. PE to the RT. The word continuous is your goal word here. Continuous. So an account that was invested at 5%. So that's going to be your R. 5% right there. Continuous compounding for 10 years. T is 10. Now contain. Oh, it says now contains. That's A. It now contains 5,900. What was the initial investment? So we want to know what P is. So we go to PERT. We now have 5,900. We do not know what P is. But E is a number. E is not a variable.
Yeah.
Your interest rate is 0.5 and your time is 10. So what we're going to do is basically divide both sides by 0.05 times 10 right now. And that's going to cancel and you're going to get your initial investment. So take 59. Let's go. I'm going to do fraction. Alpha y equals fraction. So I want 5,900 on top. On the bottom we want E, which is second division, raised to the 0.05 times 10. Answer?
It's there. Like I wrote it down.
That's my initial money that has to be invested to make $5,900. So 9. A new car is purchased. Anytime you have a car problem, it looks like this. There's no compounding. It's not compounded. It's not an E problem. Anytime you're talking about a car, this is your simple deflation formula. So a new car is purchased for $25,000. It depreciates at a rate of 12%. Write an equation function that represents the value of the car after T years. So here's your equation function. Value of your car after T years. So this is one of your answers. That's your value function. I could punch this into the calculator right now in my y equals right now. You don't have to, but I'm going to. 25,000, 1 minus 0.12 raised to the x. And now what I can do is look at my T table.
I'm sorry, because like
I remember how
I know
slow
that
it started.
Angela said it was over here.
They didn't like
I
something.
mean, that's what I thought it was. I mean, that's what I read it on.
Did my calculator just die?
What is?
Alright, my calculator just died.
Oh.
That's cool.
Let's do this again. 25,000 parenthesis 1 minus 0.12 raised to the x power. So we have this, okay? So I'm going to set my T table up so it starts at 0. Whoops, what did I just do? Second 0. Started at 0, and I'm going to look at my years. So do you see these numbers? It started at 25,000, and if you keep going down, for example, after 5 years, your car is only worth 13,000. After 10 years, the car is worth $6,962.
Okay.
After 15 years, if it's still in good shape, $3,674. So when is it going to equal 0?
Alright, so
You could scroll forever, but even after, like, say 30 years, your car, by the way, your car probably isn't running anymore, but you can still get $540 for just the parts of your car. But will it ever equal 0?
in here.
So your graph, actually, if you graph it, let's look at our graph.
Is Allison's check still in there? The 2 checks.
No, I took them out.
So why is there minus?
You can't see it, right? You need some window. Let's make sense of our window.
One for
Let's press the
Where's the
one.
one for Allison?
Window. Let's see. Number of years. Let's go 0 to
Yeah.
Okay.
2. Okay, wait a minute. X-Men.
0
0 years. We'll say 200 years by 1. Y min.
And I just kind of
We're going to say 0. Y max. The car costs how much? 25,000. So the max of the Y can be 25,000. And let's press graph.
Okay, I'm ready.
It looks like it equals 0, like right here. But what this does is it curves around. It's like an asymptote. It's never actually supposed to be 0. Okay? But it gets close to 0 right here. So let's press trace.
Oh, 2 R's.
Right here. Do you see that? That's when it's kind of close to 0 after like that many years.
I just spelled it out.
After 30 years. Actually, after 30 years, you're at 519. So we can just go like this.
ADI for first name.
After, can you see the T table? Can you see the order pair at the bottom? After 62 years, you're still at what is that number? $8. You're still at $8 after 62 years. Now it's 59 cents, 40 cents. Once I get hit to a 0, once that y coordinate becomes a 0, I'm going to say that right now it's a nickel. That's 4 cents. I'm looking at the y coordinate. That's 1 penny. That's still a penny. That's still a penny. That's still a penny. That's still a penny. That's not a penny anymore. Now it's worth nothing in 121 years. That's what I would say. But it's still not 0. Do you see if there's still decimals? But you'd say it would have to be around 120 years, so it's really worth nothing. That's what I would say. But the book says nothing. It says never. But I say 121 years. The book says never, because there is a horizontal asymptote at 0. And 10.
Trying to do that right now based on the pay.
They give you a formula in this problem.
Right.
They said the half-life of the radioactive substance carbon-14 is about 5,730 years. You actually put that in the formula. That means the life of the substance is half. Every 5,730 years, it goes in half. This, okay, it actually says that.
Is that going to help?
No.
Solve this equation to find the decay rate round your answer to 5 decimal places. So if I wanted to solve for R, I guess I would, let's take the log of each side. Or you can either go, here's 2 ways you can do this. You can go y1 equals 0.5 and y2 equals this. And see where they intersect. That's one way. Or I can take the log of each side. Take the log of each side. And then bring this out front. The log cancels. Divide both sides by this. And you should get your interest rate. So you say natural log of 5. By the way, natural log is right here. The natural log of 0.5 divided by negative 5,730 is, it says 1.20968 times 10 to the negative 4th, which means make this decimal go 4 to the left.
I mean, you can look.
I didn't recognize it.
So your interest rate is 0.012%.
I can count. You can do whatever.
That's it. Now let's look over here. So if I did it with the calculator, I'd go y1 is 0.5. That's your left-hand side. y2 is e raised to the negative 5,730, and we're going to call this x. Okay? And we're going to graph. Okay, my graph's so weird from last time, so I'm going to press on, I'm going to press zoom, 6. So there's the 0.5. Do you see that 0.5? And then the second thing we're going to see is the e raised to that. Oh my gosh, I don't see anything happening here. Did I not graph this right? I don't like this problem on the graph.
Okay. So
I think it's so small.
Go ahead and do this already.
I'm going to zoom 4.
So the only things that are in here are like what you have there, right? Within the okay. Yeah, we just.
I don't see these touching. There's a problem here. I had a problem, Houston. Did I not write the numbers down right? 0.5. Did I not see? I guess you better do it with natural logs. I don't know what I'm doing wrong on the calculator. I'm sure I'm doing something wrong, but there's the work for that. Okay, I'm done.